Perfect. On the chat, let me know if you can't hear me or if I'm speaking too soft. But I wanted to say thank you for joining us today. I am going to jump right into our presentation with why are we talking about aquaculture? You may know that aquaculture is the production of aquatic organisms in controlled conditions for part or all of their lifespan. But why would we care? I think that we're entering the perfect storm. One, the population of the world is increasing. We're just shy of 8 billion people. The environment to harvest aquaculture is a limited resource. The demand for protein is increasing, both due to the population growth and changing diet standards. And then aquaculture market is already established with strong growth projected for the future. So what are the needs for aquaculture? We at Amiad believe there is a huge unmet need for auto backwashing filtration in this market that we have begun to assist with, and we look forward to partnering more in the future. For example, filtration may be beneficial in a variety of the application stages. From intake water to grow out systems, we have different technologies to meet the different needs of the plant. Okay, so I think we're on board with why are we talking about aquaculture and why filtration, but why Amiad? Amiad has a wide range of products that are suitable for many different applications and are made of different materials. Amiad has been around since 1962 and provides solutions for our customers in irrigation, municipal, commercial, industrial, and aquaculture industries, among others. Here's a brief overview of the technologies we have, and then we'll talk about them more in depth as we go on. So on the left, we have the spin clean disc that utilizes these discs with ridges that provide depth filtration via numerous pinch points that is created when they overlap. Additionally, this technology is known for its violent backwash, so it's great for gross, sticky, organic type material. Moving into the second picture, the section scanning with screen technology is one of our most mature technologies where Amiad has devoted huge amounts of R&D developing the best screen for optimal performance and ideal suction nozzles for the optimal backwash. Our screens are known for their great performance and small footprint. The middle picture of media, we also have that, and we have different types of media depending on the application, and we have a variety of models and sizes to accommodate fine filtration needs. And then our AMF microfiber technology can be thought of as an auto backwashing cartridge filter. You receive terrific fine filtration quality with the convenience of automation. This is most known for the Title 22 applications in California. And then lastly, but not least, we have separators, and they're great for removing heavy particles such as sand and grit. And another benefit of separators is there's no moving parts. Some might refer to them as a fancy piece of pipe. There's a bit more to it, but in general, you don't have any moving parts, which makes it handy for certain applications. So as you can see, Amiad has numerous tools in our toolbox, and we can provide the best fit for your filtration need. We're not trying to force one filter into every single application. We want to have a comprehensive idea of what the application is to see if we have the best filter for that. And then this is a quick reference here of what micron ranges we can look at for each different filter type. So, on the top is our screen filters and where they operate, whether we can use the hydraulic version or the electric version. That's a typo. And then the spin clean discs, separators, media, and microfiber filters. And for reference, the human hair is between 40 and 80 micron in diameter. So when we talk about filtration, we're often talking about particles that we can see with the naked eye. And then, it gets more difficult as you get below 40 micron. Okay, jumping into screen filters. So the picture on the left is a photo of the outside of a screen. we have these cylindrical screens where particles are collected on the inside. Then when there is a differential pressure of 7 psi between the outlet and the inlet, the unit automatically goes into backwash. During the backwash, you still have most of your forward flow, with some of it being used for the flush. After the 20 seconds of backwash, the filter comes back online with a completely clean screen. Okay, getting more specific, let's talk about the screens themselves. Up top, you have our perforated and our wedge wire screen. These are great for coarse filtration of big particles. And then lower, the bottom picture, this is Amiad's special 4-layer weave wire screen, and it's fantastic for fine filtration and sometimes coarse filtration all the way up to 500 micron. One thing to note here is that not all screens are made equal. I encourage you to work with your client on what performance they are expecting out of their screen. Amiad provides weave wire screens that have an 85% plus rejection rate of the rated micron size particle. So if we say that the screen is 50 micron, it'll remove the 50 micron particles at a rejection rate of 85% at least, along with all the larger particles. So there is not a filter governing agency or a big brother going around holding all the filter manufacturers to a standard. So someone else's 20 micron screen might only have a 40% rejection rate, and then Amiad's is 85% rejection rate. And so, this is just a reminder to be aware of what you're buying and to phrase it, in ways, what performance are you expecting? Another feature that Amiad has is our spring-loaded nozzles. These nozzles do a fantastic job in cleaning fine screens because the nozzles get as close to the screen via the spring action. This allows for more efficient cleaning and less backwash water used. So what do our models look like? We have a variety of sizes, configurations to meet the needs of your plant. We have both electric and hydraulic driven filters, carbon steel, stainless steel, rubber lined, polymeric, the works. When it comes to the models that we have a variety to meet this specific application. Okay, let's talk examples, because sometimes I think it's easier to go through the examples together to see how they work. So here we have a manual screen. I know we've been talking about the automatic, but sometimes manual filters, they're just what the job requires. And here the customer just wanted to filter the big stuff before it went into the fish hatchery. So this is at 800 micron. And for reference, that's the same size as the 0.8 millimeter lead that we used to get for mechanical pencils. So, we're saying it's coarse filtration at 800 micron, but still it's quite small. Here we have our ABF brush filter, and this is with our partner Timex. The design here is similar to the screen filters, and it's just different in the fact that instead of suction nozzles, there are arms with brushes in this filter. And here we have our 1000 micron for incoming water, and the incoming water is river water, so you have a mix of both organics, your leaves, twigs, frogs, and inorganics such as sands and gravel. This is a great first step to removing the big stuff. And on a side note, the ABFT we've used in mining as well. So you can imagine it can take a really high TSS, total suspended solids load, and do exceptional on that. Okay, so we have some good intake examples, and this is a very neat look inside the hatchery. In Turkey, we have a few levels of filtration here to discuss. Stage 1, the rotary drum filter. Stage 2, a 100 micron drum filter. Stage 3, the SAF, which is the suction nozzle screen at 25 micron. And stage 4, 1 micron bag filters. So you might ask, this seems like quite a few stages. Why would you not just go straight to the 1 micron bag if that's what is required? And if we were to take the raw water right to the 1 micron bag filters It would plug instantly, and the operation and maintenance cost would be astronomical. So we found that stages are very helpful when the particle size distribution is wide. So you might have particles at 1 micron, at 5 micron, at 50, at 200. So when we target those specifically, we do quite well with stages. So we can be picky about which filter is where and what size it's at to address those size particles. Overall, this will decrease the overall backwash and wear and tear on the filters. And then furthermore, it allows for smaller stages. Because if you can imagine, say we skipped the drum filters, it might require 10 SAF 25 micron filters to handle that high load rather than just the one SAF filter. Here's an example of utilizing our EBS technology at 25 micron in Vermont. We've found that anywhere between 20 micron and 40 micron technologies work very well for zebra mussel control. And we have a whole nother webinar on that if that's up your alley and you have a problem with zebra mussels, let us know and we'll send that along as well. Okay, so those were some neat screen applications. I'm going to jump right into our spin clean disc filters. Now, the spin clean disc filters are very neat because they are polymeric, modular, and they have a violent backwash. How these work is you have these rings, and the rings have grooves in them. When you overlap them, you make dozens of pinch points that trap the particles. We put these rings on a spine, which is depicted in the left picture there. And the spine holds the rings tight. And because there are so many pinch points to trap the particles, we have ourselves an auto backwashing depth filter. Now, this is slightly different than the screen filter. A great feature of the spin clean, like I already mentioned, is the backwash. So in normal operation, the water comes from the outside of the rings and clean water is collected on the inside within the spine. When the particles build up a cake throughout the rings, the filter goes into an automatic backwash. And that's triggered again by the differential pressure between the inlet and outlet, and 7 psi is the magic number for that DP. Oh, can everyone hear me?
Yes, I think we can hear you well.
Okay. Sorry, I think I got a note that someone lost audio. Oh, and Piero, is there a dial-in number? I see Bill asked for a phone number.
Yeah, unfortunately, that option is not available.
Okay. Sorry, I just saw the chat and thought I'd check in. Okay, so continuing, when the particles build up within the discs and you hit that 7 psi for the DP, then it goes into this backwash. And the backwash means that the top of the spine releases ever so slightly, and this allows the discs to spin freely. During that time, the water is reversed through the spine, and you have tangential water pushing out and helping to clean the rings. And the best analogy we have here is it's like washing your hands, right? You have the water coming out, and then the discs are rotating very, very fast. And so there's a lot of abrasion and whatnot to help get the particles off. The backwash is 20 seconds. And then once that's over, the spine tightens again and the filter is back in operation. So what does this look like? All of our designs are N+1, because I'm sure when I was describing the last slide, you're like, oh, that means that we don't have forward flow during that backwash. Well, we design them as N+1, meaning that say your flow rate requires 5 of the units, we'll design it for 6. So this way, when one is in backwash, you still maintain forward flow with the 5 that are available. And then we have different modules to accommodate various flow rates. As you can imagine, the smaller ones on the top left are for low flow. And then the ones on the bottom right, the super galaxies, are for very, very high flows. And then this technology is great if you have organic matter because of the outside-in filtration design paired with the violent backwash. If you need more videos or pictures of what the backwash looks like or how the filter works, let us know, because we have plenty showing it in greater detail, because this is probably one of our more unique filter technologies. So where do the discs operate? We have sizes 20 micron to 400 micron to remove various particles. This chart is our experience in removing different materials using our different filtration grades. And you can see that even at a high micron grade, our 40 micron discs, let's say, they still are able to remove particles smaller because of the depth filtration and just the nature of how the discs work. You can capture particles lower than what they're actually rated for at a lower percentage. So here's an example of our smaller system with this single unit design. We call that the Opal system. And this is a two-stage system where we get the large particles out with our 100 micron discs and the smaller particles with our 20 micron. And as you can see, the incoming water is seawater. With the polymeric design, our filters can resist corrosion from tough waters like seawater. This is a similar example, but with a larger flow rate. So we partner on our projects to assist in evaluating not only what technology is the best fit, but also what model. Here, our single pod design was a better fit than the dual pod design because the backwash rate was lower despite the footprint being bigger. So we'll always want to work with the folks on site and identify what's the best system and how can we make it a win for everybody. We have another spin clean disc unit in South Carolina to protect bag filters. Because our technologies backwash on differential pressure, they will continue to provide the same great effluent quality even if there's upsets on the influent. So this is where prior to membranes or bag filters or cartridge filters, the disc filters and the screen filters that we have that are automatic and work off differential pressure are a great option because they backwash when needed. They don't require an operator to come by and press a backwash button. They are able to handle any upsets by increasing the backwash off of knowing that, okay, the particles are building up faster. This project in Israel is a particular icky one because of the fish scales, and it is that it's designed to remove. The polymeric discs do a great job in removing the sticky, slimy material. Here we have the clear domes on that bottom left picture. And it actually shows one of the units in backwash. So if you see, there's a black dome and then a clear dome with the green discs inside. And then the middle dome actually looks like white discs, but it's actually the backwash. And then that far dome is green. So, as you might notice, two of those filters are in operation right now, and one is currently backwashing. So just that picture using our clear domes so you can see it. In Australia, we have a larger installation pulling in seawater. This is what we call our galaxy configuration, where there are 5 spines in each of the black units pictured there. This install has isolation valves for further improved maintenance. At Amiad, we recommend yearly maintenance of all of our filters, where the client pulls apart the filter, inspects them, and replaces the small items like O-rings and whatnot. And at that time, looks at the discs, makes sure that they're still in great condition. We expect our filters to last 15 plus years. Often with the discs, they last 5 plus years. If they're removing organic materials, they can last longer. The spare parts are not expensive, and we don't have any spendy rebuild kits. The yearly maintenance is for the small stuff typically. And really, if you have the filter apart, it kind of makes sense just to replace O-rings and the little stuff. Okay, so in Canada, we have our spin clean disc filters at 20 micron for UV protection. So many UV manufacturers like 20 micron filtration prior to the units to improve the performance of the UV. And this is something that we see in the aquaculture world quite a bit. Okay, so we've covered screens, we've covered discs, and now we're on to media. So many of you may be familiar with media, but just a quick refresher is typically it's sand or gravel in a tank, and the raw water enters on the top and it's applied across the media. So then the water percolates through, allowing particles to be trapped within the media, and clean water is harvested at the bottom. Amiad has a variety of media tanks and media types. Of particular interest to our discussion is our fiberglass and our polymeric media filters. We also have our PEP active media, which is a neat media we use in industries from oil and gas to irrigation. This media is crushed glass that has a negative charge. It does a great job on organics and has a very long lifespan, 15 plus years. For reference, standard sand is typically 5 to 7 years. This is a depiction of how the PEP active works. You have the negatively charged PEP active glass, the green, in the middle, which creates zeta potential around the glass. And then both inorganic and organic substances are attracted to the media. When it comes time for backwash, the water removes the contaminants from the media. We especially like this media for organics because the glass is not porous like sand. And under a microscope, we see when there's organics in sand, they slowly build up and build up and build up because the sand just has so many places for the bacteria to live in. And even after backwash, it's hard to get that sand completely clean. But with this glass media, we're able to regenerate the glass, and it looks just like it did prior to being in use. So where do we use media filtration? If you need fine filtration that can handle a high TSS load, this is the option we want to look at. So we have polymeric tanks and the PEP active here, and it provides under 10 micron filtration for this hatchery. And it's also taking on seawater, utilizing our AGF, which is the polymeric unit, the red unit there. That does a bit better than, as you can imagine, our carbon steel or our stainless steel tanks. In Australia, again, seawater is filtered directly with the polymeric AGF at 20 micron. And in Hawaii, we have a neat installation by Ocean's Design where our disc filters that we spoke about earlier are used prior to the media. So the disc filters are at 55 micron, and the media provides 10 micron filtration. So even though media can typically handle high TSS, total suspended solids, meaning dirty water, sometimes pre-filtration is a good idea to prevent large particles from being fed to the media. As you can imagine, if a large particle goes in through the top and then it just sits on top of the media, it creates a channel of good clean media underneath it. And so then you go into this premature backwash, even though you still have some usable media right under that big fat particle. So this staged filtration allows the media to be as optimal as possible. And that's really important because media filtration does require quite a bit of water for backwash. So you really don't want to trigger a backwash too soon. Okay, for our microfiber filters. So this is called our AMF, our automatic microfiber filter. The easiest way to think about the filter, as I mentioned earlier, is that it's an auto backwashing cartridge filter. Now, when you open it up, it looks a little more scary. There's quite a few cartridges in each filter, and we can go through that. We also have some videos on how it operates if you have interest in the AMF. So we have various sizes of the AMF for different flow rates, and we offer the AMF in 2 micron to 20 micron cassettes. And then it's great for fine filtration, low operating pressure, low self-cleaning flow, and it's NSF 61 certified as well as Title 22 certified. One thing that I kind of forgot to mention with the screens and discs is that we do require quite a bit of pressure for the filters to use their auto backwashing feature. In general, we recommend 30 psi operating pressure, and then depending on how fine of filtration, anywhere between 30 psi for the backwash to up to 75 psi for the backwash. And that's all very dependent on your application, what you're trying to remove, and what size micron you want to get down to. So again, we would work through all that together on each application, case by case. Okay, let's talk about performance. So here you can see the filtration efficiency on the left, and then on the right, I think a picture is worth 1,000 words here. The cups left to right are inlet, outlet, and backwash. So this is pretty neat, and this is a great filter for removing turbidity. When we talk about water, we can talk about TSS, total suspended solids, which is a physical measure. It's if you dry a liter of water, what's actually left. TDS, total dissolved solids, and that's going to be talking about your dissolved minerals in the water, mostly, like your calcium, magnesium, and sulfates and whatnot. And then turbidity is a funky one because it is more about how the light hits the particles and if they reflect, refract, or it's really about how the water looks. So we find that for turbidity removal, most often you need to be under 2 micron for good turbidity removal. Again, depends on a lot of things, but just in general. Okay, so here we have install in Washington State, and it's meant to protect the UV system using 3 stages: coarse filtration, spin clean disc filters, and the AMF filters at 3 micron. So there are 3 AMFs here because the customer needed constant forward flow. We could do this with 2 AMFs, but when one goes into backwash, it is completely offline for 10 to 15 minutes for that backwash. So here's the 2+1 design. And, there's ways we can work around, utilizing a brake tank or cartridge filters as a backup. But the AMF, it does such a great job cleaning. I'd say one of the biggest things to be cautious of is that it will have to be completely offline for the backwash. Okay, so now I will turn it over to my colleague Eyal for more examples.
Hello, everybody. I will start with this. Can you hear me?
Yep, I can hear you.
Kathleen? Okay, right. I will start with Iron Aqua. Over there, we are filtering river water. And the reason they selected Amiad solution is that the previous system using old small pool filters and cartridge couldn't cope with the load. The turbidity was too high, and in order to protect the new hatchery and ozone and UV systems, they wanted something that will be more reliable and can handle a bigger variety of water qualities. So the process was having the Alkyl AGF filters with the PEP active media inside, followed by the AMF 93K 2 micron. As you can see in the table on top, the feed water are changing all the time, and especially when there is rain event, you can see high turbidity of feed water from 39 NTU and up to 85 NTU. This is pretty dirty water already. After the AGF filter, we managed to remove quite a lot of the turbidity. And if you look on after the AMF in this table, you can see we can go down to 0.9 or 2 NTU. This is basically the clean water you saw before. So from quite dirty water to clean water. The last technology that we didn't discuss yet is our centrifugal separator. Separator are the easiest technology to remove sand or heavy particles out of the water. Any particle that have a bigger specific gravity than 2.6 is easily removed by the hydrocyclone. We will use them many times as the first step to remove mainly sand out of water, or any big shells or fraction of shells out of seawater. In that application, we filtering the Mediterranean water. It's a seawater coming from a shallow bed intake. First line is the hydrocyclone, removing the sand and any heavy particles out of the water. And then we can go directly into our 20 micron Galaxy system. Sprinkling these filters, you can see them on the bottom right photo, to protect a hatchery for a big hatchery for many different types of seawater fish. As Kathleen mentioned before, we believe in the multiple steps of filtration because each filtration step will remove other particles from the water and make it much more efficient filtration system. In Hillary's, it's one of our first multi-step solution we put more than 15 years ago now. Over there we have screen, like basket strainers, on the intake. And then if you're going from the bottom up on the photos, followed by our hydrocyclone systems, removing the sand and shells. The disc filters that will filter out any organic material and larvas, preventing the growth of any mussels and crustaceans inside our media filters that basically supposed to do the turbidity removal in this application, to give the clean water to the facility. As Kathleen mentioned, we are a house of technologies, meaning we have many different technologies we can offer, and we want to offer our customers the right technology for the application. We don't need to offer you a specific solution or just one technology because this is what we can offer. We will always select the technology to suit your application on site. And that's actually a sample of a project we did in Australia, in Batavia Coast. It's a big research place that growing the clownfish, or the Nemo as we like to call them here. And over there we use most of our technologies, filtering the raw seawater coming into the facility, and then filtering all the effluent coming out of the facility. The flow rates, as you can see, are 528 GPMs coming in and out, and I will go through the process in the next slide. On the inlet side, we started with hydrocyclone, water coming from the pumps from the intake, going through a hydrocyclone system. Over there, we control the hydrocyclone system by a PLC, meaning we opening and closing different units. Because they're changing the flow, we want always to maintain a stable velocity through the hydrocyclone to have efficient removal of the sand. We need, on hydrocyclone in general, we need to lose 7 psi, to have 7 psi head loss all the time in order to have an efficient separation. From the hydrocyclone, the water went into a 70 micron disc filter, again, to remove all the larvae and the organic material, to prevent them later on growing inside our media filters. The media filters in this case, it's the third stage, filtering and improving turbidity of the water using AGFs and PEP active media in them. Follow the media, some of the water going directly to the facility and a smaller stream of water going to our microfiber filter 2 micron to provide really clean water to some of the aquariums on site. After the water been used, they're coming back as effluent from the facility, and they wanted us to offer a solution in order to clean the water so they can re-inject them into what we call a beach bores or wells, so they can get rid of the water. But in order to prevent blocking those bores, injection bores, they needed to clean the water quite a lot. So the first stage, we used our ABF screen filter to do 3,500 micron, and then followed by AGF to polish the water and to get them clean enough for the injection. What we did here was another step. We collected all the water from the backwash of both technologies and sent them to our Timex high drum filter. The drum filter purpose in this application was to concentrate the backwash water even further, and then we collect the solids only into evaporation pod or geobag, so we basically don't discharge any water out as a backwash anymore. So that's a full example of how can we use Amiad technologies, the hydrocyclone, the disk filters, screen filters, and media in one facility to basically complement all necessary or all the application needed on that specific site. I will pass it now back to Kathleen.
And that's all we had for you. We have different resources, both our websites, but also on YouTube, on videos on how our filters work. And of course, reach out to us anytime for information or if we can help with any application.